found it. Alison is asking, hi, can you test a 12-volt lead-acid AGM battery with your tester? Charging and trickle test for ampere hours, if you can, as this will help all with older batteries. Please help with one run with and without trickle test. Well, thank you for your comment and suggestion, Alison. I have spared neither effort nor expenses and bought some AGM batteries for our test. Welcome back to the Off-Grid Garage. Okay, so let's see what we have here. 12 volt, 9 ampere hours, AGM deep cycle battery, T-Power. I bought them from Land Plus here in Australia. It's the ML12-9U. And despite the fact we've got all these information now, and I did some Googling, some researching, I couldn't really find any specifications for this type of battery here online. If anyone can find something, yeah, please send me the link for it. So we have to go with the specs written on the battery itself, and also find some information online about AGM batteries so we can go with them as well. Okay, so first of all I want to determine the state of charge of these two batteries here by measuring the open circuit voltage. Okay, first battery has 12.96 volts open circuit voltage. Well, as per our list here, this is 100% state of charge. The batteries are now resting for several days now during the transport. Okay, let's measure the second battery. And this one has 12.52 volts, which is a little bit over 75%. So even these batteries here, are called deep cycle batteries. I would not recommend discharging them lower than 50%. So DOD, or depth of discharge, of 50% is really recommended. This probably gives you a cycle life of about 600-650 cycles until you hit the 80% state of health in these batteries. But if you really use them as deep cycle batteries and you discharge them up to 80%, which you can, the cycle life will go down from 600 to only 400 cycles. So I would really recommend keeping the depth of discharge as low as possible. Well, and we all know this is a big disadvantage of any lead acid battery. The depth of discharge is just not there, so you can only... So of these 9 ampere hours capacity of this battery here, we can actually use only around 7 ampere hours maximum, super maximum. Better only 4 to 4.5 ampere hours just to prolong the battery life. Okay, let's have a quick look at the specs here. So cycle use is 2.4 to 2.45 volts per cell. That is per cell. That says per cell. And this is a 12 volt battery, so we've got 6 cells in here. So we have to multiply this by 6, which okay. So this gives us a maximum charging voltage of 14.4 to 14.7 volts maximum. And then we should let the battery absorb, and afterwards we can reduce the input to the float voltage of 2.26 to 2.3 volts, which is 13.5 to 13.8. And the initial current in both cases, so what it says here, 0.25 C, and then there's a little 20. Can you see that? The 20. This is for a charging time of 20 hours. So how I read this here, the initial current can be a quarter of a C, which is 2.25 amps. So you multiply 9 ampere hours by 0.25, which gives you 2.25 amps. But I think this is only the initial current. I'm not sure how long you should actually use this here. I had a look at other AGM manufacturers, and they actually recommend charging the cell only with 0.1 C. A 0.2 C rate is already considered as fast charging for AGM batteries. So I'm not sure what kind of AGM batteries you are using for your solar systems, but this sounds like a very small current only. And they recommend a charging time for these batteries here of 20 hours. And then we have a very interesting specification up here, it says C20, which is nothing else than 0.2 C, at 20-hour rate down to 1.75 volts per cell at 25 degrees. This is for discharging this battery here. So 1.75 volts. This gives us 10.5 volts as the lowest voltage we can discharge the battery to. And looking at our table here I found online, well, 10.5 volts, this is far, far, far below 0% state of charge of the battery. But well, this is what it says here, so this is the specifications on the battery itself, so they should be okay, right? But 10.5 seems to be very, very low for an AGM battery. So this will actually hurt your battery already if you discharge that low. Well guys, anyway, let's get cracking here. We've got an order from Alison to do some testing with these batteries. So how should we charge these AGM batteries now? Well, it's fairly simply, they're using almost the same process as lithium iron phosphate batteries. A constant current charge at the beginning to charge the bulk amount of energy into the battery, and then an absorption phase with constant voltage. And then we can wind down back the voltage to a float stage to compensate for discharge and keep the battery 100% charged. Well, most manufacturers actually don't tell you how long the absorption phase should be for AGM batteries. It is not like with lithium iron phosphate where you have a cutoff current or something. Most forums and websites only say, well, you should have them on absorption for a certain amount of time. And some specify 2 hours, others say 4 hours, and you can also find information up to 6 hours. Well, most websites talk about using an automatic charger for these AGM batteries, which takes care of all the charging phases, so they don't specify anything at all. So what I have found is you shouldn't keep the battery on the absorption voltage for too long. So our absorption time is 14.4 to 14.7 volts, and because it's a bit colder at the moment here, well, the battery is only 17 degrees Celsius or 62 Fahrenheit. We can actually increase the voltage slightly. The colder the battery, the higher the charge voltage can be. So as per the label on the battery, the charging voltages are measured at 20 degrees Celsius. So I think in this case we should totally ignore the temperature coefficient compensation calculation, and we charge the battery to 14.7 volts as the maximum. And then we will absorb to 0.1 amps. This is what the tester can do, and see how the charging curve looks like. Okay, I'm just reading Alison's message again, and she wants us to do a test with and without trickle charging. I'm not 100% sure what she actually means with that. How do you trickle charge an AGM battery? Is this just floating then? So does she want us to charge to an absorption voltage and then in the next test only to a float voltage and see what the difference is? I think eventually you will charge the battery to 100% anyway. Floating just takes longer. But let's start our EB tester software here. And I would recommend we fully charge the battery now to 14.7 volts. Let it completely absorb, so it's 100% full. And then we do a full discharge test to 10.5 volts, as per the specifications on the sticker on the battery. And we do this with a 20-hour discharge rate. This takes 20 hours then to discharge. This is one of these tests which takes forever. So we've got 9 ampere hours. So discharging over 10 hours would mean 0.9 amps. And they want us to do a 20-hour discharge. So this is only half of the rate. So we're discharging the battery with 450 milliamps, 0.45 amps, as per the specifications on the sticker on the battery. Okay, let's do a constant voltage charging up to 14.7 volts. with 0.9 amps. This is 0.1 C for the battery, so totally safe. And then we have a cut-off current of 0.1 amps. And then we consider the battery full, right? So we're going to fully charge the battery first, and then we talk again. Oh wow, we already have reached the 14.7 volts, and you can see the red line already tapering off. So the current goes down quickly, so the battery is actually 100% charged. Okay, this may still take half an hour or so to fully charge the battery now. Okay, I'll see you again when the tester turns off. And we should do a full cycle test and a capacity test first, just to give us an idea how much ampere hours we can actually get out of this AGM cell. And then we do the full absorption test later on, and the trickle test with the float voltage again. And then we have an idea how much capacity we have actually charged into the battery. If we don't know the full capacity of the battery, these numbers don't say much. Much later. So it is now the next morning, and we have our graph here from last night's charge to 14.7 volt constant voltage, and with a cutoff of 0.1 amps. And this is in the beginning of the graph here. We can see the current tapering off quite quickly after we reach the 14.7 volts, and then it takes a long time, about 2.5 hours, until we reach 0.1 amps, and this is the lowest setting we can program in the tester. So an absorption time of 4 hours is, I think, appropriate for AGM batteries to reach really 0 amps and 100% charge. We overall have only charged 418 milliampere hours into the battery during this time. And then I clicked on the monitor button here in the tester software, which actually lets the graph run even after the test has finished. Usually the graph will stop when the test is finished, but in this case the graph keeps going, and I wanted to see what actually the voltage does when we take away the charging power. And you can see here from 14.7 volt we've got a steep drop down. Within in less than half an hour we dropped the voltage to 13.2 volts from 14.7, and this is probably a good resting voltage. So if we have another look here in this table, 13.2 volts is 100% state of charge of the battery. They recommend actually resting the battery between 12 and 24 hours before you do the open circuit voltage measurement. It takes that long for AGM batteries or lead acid batteries to actually dissipate the charge on the plates. So it equalizes out the energy density in the chemistry. Well, now we have waited only 7 hours, and the battery voltage has now dropped to 13.08 volts. Anyway, let's continue. I have already prepared our tester programming here. So what we are going to do, we are going to discharge with constant current of 0.45 amps. And this is a rate, this is a 20-hour rate for this 9 ampere hour battery. And we were going to discharge to 10.5 volts only, as per specs on the label again. This is not my idea. I think this is far too low. And afterwards we do an immediate constant voltage recharge to 14.7 volts again with 0.9 amps. Now we can recharge the battery with 0.1 C. And then we've got a cutoff of 0.1 amps again at the end, so we will have a similar result as here in the curve shown just now. And then we have a wait period of 6 hours. And these 6 hours should be alright to take our first open circuit voltage measurement on the terminals of the battery. This is the resting time you should give the battery after charging before you actually measure the open circuit voltage and then determine the state of charge of the battery. Alright. Without further delay, let's get started. Yep, fan turns on, and this will be a 20-hour discharge, and then we have about a 10-hour charge again, so this is 30 hours plus a 6-hour wait period. See you next week.
3 weeks later.
Guys, it looks like the wait is over. We have now fully discharged and recharged the AGM, the T-Power 12 volt 9 ampere hour AGM battery. And this is how it looks like. Look at this ridiculous curve here. Look at this nice arch here. Goes all the way down to 10.5. I'm not confident with 10.5 volts discharging an AGM to. And then we have quickly recharged the battery again to 14.7 volts. Is that correct? Yeah, 14.7 volts. And then the current tapered off because we have set a 0.1 amps discharge threshold. What I'm totally disappointing with this battery is now is, if you have a look here at the top right where we have our table, step number 1 was the discharge with constant current of 0.45 amps, and we could get a capacity of 7.62 ampere hours only. Remember, this is a 9 ampere hour battery. So I'm not sure if the battery wasn't quite full all the way, if there was something missing. If you charge it to 14.7 volts and then let it fully absorb for this was over 4 hours. That is basically from here, from this line, roughly a little bit further actually, from there all the way up to here where the red line goes to 0. This is over 4 hours. So we let the battery absorb for over 4 hours until the current hit 0.1 amps. I think the battery was totally 100% fully charged. And we did the discharge as per the recommendations here on the sticker. 1.75 volts per cell. We've got 6 cells in here as a battery, 12 volt battery. And this is 10.5 volt. And we got only 7.6 ampere hours out of it, not 9. So that's a bit disappointing, I think. Well, anyway, and then we did a constant voltage charge to 14.7 volts. God, it totally confuses me with all these voltages now between the AGM system and the lithium iron phosphate system. And then we recharged to full 14.7 volts again and could charge 8.155 ampere hours into the battery, which makes sense. You always charge a bit more into the battery because of losses, heat losses and internal chemical losses the battery or the cell has. So these two numbers make actually sense. But why does it have only 7.6 ampere hours on discharge? That's not good. That's not good enough, I think. Well, and then we waited for about 6 hours. I just wanted to see how far down the actual voltage goes after the cell rests. And now we are at 13, here top right hand corner, 13.16 volts rest voltage. So this is 100% fill rate. Here, if you have a look at this table again, 100% state of charge is 12.85 and we are still at 13.16. So the battery should be fully charged, right? Anyway, I have read Alison. Sorry, I have read Alison's comment again. I'm not really sure what she means with trickle charge, but I think she means float charging. So this was basically the first run she wanted me to do to charge to 14.7 volt maximum cycle voltage. And now we do exactly the same test again. Discharge the battery to 10.5 volts and then charge it only to 13.7 volts. 13.8, which is the highest float voltage this cell can actually do. And then we do a full absorption to 0.1 amps again and see if there is a difference. I think there isn't. It just takes longer to fully charge the battery, but we should see very similar results to actually this one. So I will save this curve here now as picture and data for you guys. I put this on my homepage again. So this is a good example for AGM lead acid battery fully discharge and charge curve again. And we do exactly the same test again. Well, this takes another 2 days then. I need to let the computer run with a program all the time then to draw the curve for us. Okay, I think I have programmed now the tester here correctly. So we're doing a discharge to 10.5 volts again. Then we do a charge to 13.8 and wait until the current drops below 0.1 amps. And then we wait for another 6 hours again to have this rest curve in the graph as well. Alright, so say OK. Just checking here again. And start. Interestingly, the fan doesn't turn on the tester. It is probably so cold outside, or in here in the garage, that the fan doesn't turn on. Okay guys, I guess 0. It will take a long time. That's a 2-day test again. Thanks Melanie, Melissa or whatever you're, Alison.
1 eternity later.
So this is like another 37 hours later, and we've done a full discharge and charge now again with the AGM battery again to 13.8 volts, including full absorption. It took about roughly 4 hours to absorb the battery at 13.8 volts. Well, apart from that, it looks very similar to the other curve, right? So I don't know, looking at this curve we did before, charging the battery to 14.8 volt, it looks like we had actually a longer absorption time. 30, this is 4 hours. A little bit less than 4 hours it took to absorb at 13.8 volts. We have charged 7.5 ampere hours into the battery, while we could discharge 8.2 ampere hours. Going back to the other curve we did before, I don't have any figures here at the moment. I put them here on the screen, but I think we had less capacity available actually when we discharged. See, it discharged only to 7.6 ampere hours here. I don't know, this seems to be very inconsistent for some reason. The same tester, same temperatures, everything the same, but we have a much longer absorption time at 14.8 volt than we had at 13.8 volt, which I was expecting would be the other way around, but apparently not. Well, I'm still not 100% sure what Alison means with trickle charging the AGM battery. Does this mean we charge them very slowly? I mean, 0.1 C is very slowly already. Is this already trickle charging? I don't know. Well, if you want me to do a test, be very precise what you actually want me to test. This is a bit vague here. I'm not 100% sure how to. Well, anyway, I will save all the pictures and all the data again on my website. Link is down below. If you want to open these CSV files with the EB tester software, all the links are on my website. Everything is explained there. At least we've got a discharge and charge curve now for different voltages for AGM batteries. I've got another 8 or 9 suggestions, tests with the lithium iron phosphate batteries. I mean, who is using AGM batteries for solar storage? This is just 0.1 C of charging power. This takes forever. How do you... And then the discharge rates are not great either. This seems to be really something for UPSs or solar gates or something, you know. But for solar storage... Alright guys, as always, thank you so much for watching. Thanks for all your support here on the channel, for all your beer donations. Stay charged, stay safe, and we shall see us again in the next video coming out very soon, right? I'm sorry, Alison, I couldn't get more information out of your comment, and you didn't respond, so I'm not sure what to test else with the AGM batteries, so I need to clean up this mess now here. Look at all these cables here and battery stuff and testers and... What happened here last night?